Alright, so we're going to be doing the 23rd problem in the grind 75, moving on to the 23rd. This one is called middle of the linked list. So we're given 20 minutes, so we'll start the countdown now. Middle of the linked list, okay. Given the head of a singly linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. Okay. Return the second middle node. So yeah. Unfortunately, I know how to solve this problem already, so it's not like I've never seen a problem like this. Basically, we use two pointers, a fast and a slow, and the fast pointer moves by 2 spaces each time, and the slow pointer moves by 1 space every time. The only thing that I will have to look out for is making sure that I don't run over the edge of the list. So let's just think about it here. So if both of them start out here, we can do, next, next, then next, next. Dot next would be null, so I would not go. But if we do, next, 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 next. So this would mean if I did that, what can we assume? So we can say, as a base case, if head.next is equal to null right away, then we can simply return head because we have a node of length 1. Also, if we have 2 nodes, they're both the middle, that means we should return the second one. Okay. So I'm going to say we're going to create 2 pointers. This one's going to be called list node fast. It's going to be equal to head in the beginning. And then list node slow is going to be also equal to head. And we're going to say, well, fast.next does not equal null. Hopefully I believe that should work actually. So let's say we have a linked list with 2 elements. Well, fast.next does not equal null. So we're going to say fast.next would technically be equal to null. So would we return slow.next? Would we return that? Well, let's see. If we have a list like this, let's just go through it. So while fast.next is not equal to null, we would set fast equal to fast.next. We would set slow equal to slow.next. So this fast.next would go here, slow would go here, fast.next would go here, slow would go here. While fast, okay, hold on. Fast.next does not equal null. Right, so we have these 2 cases though, because in this case we would just want to return slow, because slow moves twice and fast also moves twice like that. So let me just how do we get around this? We have 1, 2, 3, 4, 5, 6. Let me think. So
So if we just said fast.next does not equal null, let's see. So fast goes 1, 2, fast.next equals null. No, it does not. So we can do 1, 2, fast.next equals null. Yes, it does, so we will not go on. But if we're here, we do 1, 2, fast.next is not null. 1, 2, fast.next is not null. 1, 2. Yeah, that should work actually. But let's make sure slow pointer ends up at the right place. I think it would be that. So 1, 2, 1, 2 equals null, so we return that. 1, 2, 1, 2, fast.next is not equal null, so we do 1, 2, and then we return that. So again, 1, 2, 1, 2, 1, 2. That's 3 steps. So that's 1, 2, 3. So yeah, this algorithm should return the middle node or the second middle node. Yeah, and I believe that's all there is to it. I don't think there's any syntactical issues. So we've accounted for if we have a linked list of length 1. If we have a linked list of length 2, we can think about that really quick. Fast and slow. Well, fast.next is not equal null. We'll go 1, 2. Fast will end up on null. We'll move slow over to the next one, and we'll return slow. And since there are technically 2 middle nodes, we will return the second one. And yeah, just trying to check every case, but I believe that's all there is to this problem. We're going to run the code, see if it works. Yep, that works. And let's see, null pointer. What does it say? For 6. Is null. Okay, so this is the 1 through 6. Okay, so they both start off on the head, right? We go 1, 2. Okay. And we go 1, 2. And we go 1, 2. I think we also have to check if fast equal to null first. Well, fast does not equal null, or fast.next does not equal null. So if fast.next equals null, that means we can go from fast to next to null. However, if we do 1, 2, 1, 2, and then 1, 2, but then we check if fast.next has a null, there is no next on a null. Fast itself is null. So that's why we have to have this check before. I will make note of that. And I believe that's all there is to it, actually. So this is for the 1, 2, 3, 4, 5. Okay. So let's see. 1, 2, 1, 2. While fast does not equal null. Be and fast.next does not equal null. No, it could just be or, because again, if fast is null, then it will not have a next. But it's if one of them are true. Yeah, so they both have to be. As soon as one is false, essentially you want to break out. Yeah. Jeez. Okay. That should be pretty self-evident. Yeah. Okay. All right. That part took me probably like 7 minutes to get. I knew everything else other than the proper uh, condition for the while loop. So I'll definitely make note of that and talk about it a little more in the solution.